Hello all, welcome back to Code Today let us solve the LeetCode's daily challenge, and the problem is the number of nodes in the subtree with the same label. So you are given a tree that is connected under a graph that has no cycles and have n nodes from 0 to n minus 1. And what they have said is, and they have also given the labels of this node. 1 is represented by this string labels 0 1. So you can see the at first index the label is b, so the node b has a label b. And for the third index, which is e, 0 1 2 3, so 3 has a label e. So this is what the label string represents, or for each node there is a label. And they have also given the edges which are all connected, undirected graph, so it will be connected in both ways. And what we have to find is, we want to find the number of nodes in the subtree of the ith node which have the same label as node I. That is, if I am at this node, I want to find the number of nodes which is having the same label b which one has in their subtree. So in this subtree, including 1, this 1 is also included in that subtree. 1 4 and 5 is the subtree for 1. And we want to find the number of nodes that has a label b. There is only one node which is having a label b is 1 itself. So we will say answer of 1 to be 1. As you can see, answer of 1 to be 1. Let us say, let us calculate the answer of 0. Answer of 0 is nothing but the number of nodes in the subtree having a label a. So you can see the number of nodes that are having a label a is nothing but 2 and 0. So there are two nodes which is having a label a in the subtree of 0. So we actually have answer of 0 to be 2. So this is what the problem states. We want to find for each and every node, we want to find the total number of nodes that is having the same label of the node I. So we want to calculate this answer array and we want to return this vector. So how can we return? So how can we solve this problem? So actually, to solve this problem, we can actually use a DFS function. In that function, what we can do is, we can calculate on the go. That is, we can just do a DFS function in bottom up manner. While doing that function, we will say that function, let us assume that function is going to return some vector of size. It is going to contain only lowercase characters, right? It is going to contain only lowercase characters. So let us assume that that function is going to return a vector of size 26, and that is going to have the labels, in the sense the count of labels. So on the go, we will calculate the count of labels in bottom up fashion. So when we get the count of labels, we will just update the answer of node answer of I is equals to the count of that array, or count of that vector I, right? So how I'm saying is, let us assume that we are having a function. I'm just declaring the function vector int. This function is going to return me a vector int, and let us say this function to be as count labels. This function to be count labels, and I'm going to pass some arguments. Let us declare later. So this count labels is nothing but, this is going to return me a characters, or let us say number of labels or label count. What we can say it as number of labels. And how I'm going to say is, answer of node u is nothing but the number of labels of u hyphen a. Labels of u gives me a character, and labels of u minus a gives me an integer, and that particular integer will be having the total number, total count of the subtrees. I am assuming that it is going to give me the total number count of the subtrees of label that contains at that particular node u. So this is how we can just update. So let us quickly build the main code, and then we can come to the function, so functional, so that you will get a clear understanding what I'm trying to say. So what I'm going to do is, first we want to create a graph of size n. So we can have a vector int graph of size n, and we should not run, we should not stuck into a infinite loop. So we can have a vector of int visited of size n, and we can initialize it to 0, and we are going to pass this vector, visited vector, to the function as well. Then we can just create a graph. Now create a graph. How we can create? For auto edge, in my edges, what we can say, graph of edge of 0 dot push back of edge of 1. Similarly, we can just create another graph using this condition, using this line. We have just created a graph. Now what we can do is, we can just call the function count labels, and I'm assuming this is going to be a recursive function, and this is going to do a DFS bottom up manner, and it is going to calculate the total number of counts of that particular label in that particular node. So count labels function, and I'm going to pass graph. Then what I can just pass, I can just pass the labels vector, and I can just pass the visited vector as well, and I should pass a node u. But it should, in our problem it states that this, it starts from the root node 0. The root of the tree is the node 0, and each node has a tree label. So we can just start from the node 0, and finally I'm going to return the answer, and we should also pass the answer vector, right? So we can just pass the answer here, and we can just declare a vector of answer, vector of int answer of size n. Yeah, it makes. Now what we can do is, we can just pass here vector of int graph, then vector of int labels, and vector of int visitor, and I'm just going to have the node int u node, and I should also have a vector of int ans, right? That is going to store my answer. Now what we can do is, we can have a base case. What is our base case? It should not stuck in an infinite loop, so we should check for the condition whether it is visited or not. If it is already visited, we can just return. This will be my base case. Now what we can do is, we can just go for the recursion case. But in recursion case, what is that we are going to do? We are going to go for all the adjacent nodes, that is recurse through the adjacent, through the neighbors, let us say neighbors. And how we can do that? For auto neighbors, in my graph of u, we can just call this function count labels function graph, then labels visited vector answer array, and the neighbors passed. And this function, I'm assuming that this function is going to return me some vector. That what I'm going to do is, I'm going to get that vector, and then I'm going to accumulate the answer. Accumulate the answer in the sense, I'm going to calculate the total number of subtrees for all the characters, all the A to Z characters. So I will just say characters is equals to this, and for int I equals to 0, I less than 26, I plus plus. This for loop is nothing but accumulate all the labels of subtrees. That is what this is doing. So we should have a vector here. We should declare a vector number of labels, right? Vector of int number of labels of size 26. I am going to initialize it to 0, and this can be at the top because we want to return in our base case also. So we can just have number of labels. We can just return number of labels if it is already true. Then what it does is we can just have a dry run. What it does is we are at this point 0, and we will, since 0 is not yet visited, we will just visit them. Visit of u is true. Okay, we have visited them, and we will be moving to this neighbor 1 using this for loop. And what we are going to do is, since 1 is not yet visited, we will go to 4 and we will just go for its neighbors. 4 is not yet visited, we will just visit 4 and we will go to its neighbor, which is 1, and 1 is already visited, and we will just come out of this loop. We will just come out of this loop. After coming out of this loop, we want to just update the number of labels vector. How we can just update the number of labels? Number of labels of u hyphen a plus plus. Why we are doing this? We are just updating the labels, updating from the labels. Labels string is nothing but this is a string, sorry, labels is a string. This labels is nothing but for that particular node what is that label it contains, that is what it is represented by this label string. So we can just take the labels of u, we will get an alphabet, minus a we will get an integer, and that particular index we will just increment it because this node 4 has a label d, and we want to increment, we want to make a count, right? Because for this subtree 4 we are having only one node which is having a label d, and which is having a label d, which we are having only one node, and we have just make that count, we have just counted it, and we also updated it in our answer vector, and we are returning this number of labels to our recursive function, to which is stuck here, which is there in the stack, right? Recursive stack. Now when it goes to the other neighbor, which is this 5 in this for loop, what it does is again this 5 will be computed and we will get some number of labels, and we will just update answer of 5 is nothing but 1. And then when we end this for loop, what we are actually doing is we are just calculating the number of labels. Number of labels of I is plus equals to the chars of I, so that we are just accumulating all the labels of subtrees by this for loop. That is what we are doing. When we backtrack, we just need this updation, or else we will lost, right? So when this particular node 1, I need to calculate, I need to know what are all the subtrees that is having the labels, and what are all the subtrees that is having the labels from A to Z. If I don't know that, I cannot update the total number of nodes that is having a label B at particular node 1. So that only this for loop helps here to accumulate that. So now let us try to run our code. I hope this is clear. Okay, let us see what is happening here. Invalid range expression. Okay. Yeah, actually the error is here. Vector of int I should give like this. The syntax is like that. Great, it gets accepted. Let us try to submit our code as well. So the time complexity for the solution will be order of n, and the space complexity will be also order of n. Yeah, great, it gets accepted. Hope you like the solution, and let me know in the comments if there are any suggestions. And I hope you like the clone code, and it is pretty simple as we did in the yesterday's problem. This is our main code main stub, and we have created a graph, and we are just calling the function, and we are assuming that this function is going to return me some vector which is going to be of size 26 a to z. It is going to have all the counts or till now from bottom up fashion. That is what we are actually assuming that this function is going to return, and we are just declaring, and if it is a base case we are just returning the empty vector of number of labels, and or else we will just visit them, and we will go to all its neighbors. While going to all its neighbors we are just calling the function, and this function is going to return something, and that function we will be having some vector int of size 26, and we will have the counters. And this for loop is nothing but we are just going to count all the subtrees of all the labels, and once we have accumulated it, we are just counting the current nodes label. This is what that this statement does, and after which we will just update our answer of u. That is what we are doing here. And yeah, hope you like the solution, and let me know in the comments. Until then, bye, and let us see in tomorrow's LeetCode Daily Challenge.